Good afternoon, everyone. Thank you very much for coming here to these sections. Today, my presentation next is about connectivity and disruptions, geospatial insights on North Carolina transportation resilience. So I was asked to introduce myself a little bit. So my name is Trung Tran. I'm a associate professor of geospatial science at Fairfield State University. I'm currently the program coordinator and director of the geospatial science program and GeoINT program at Fairfield State University. So if you are students here, if you are interested in geospatial science and GeoINT, please come see us. I've been working in GIS since 2002 and do a lot of things, programming and analysis, and also do remote sensing for my PhD. So I felt I'm very interested in integrating GIS and remote sensing into different applications, especially in transportation, natural hazards, and land use and climate change. And so this particular presentation is actually one of the outcomes of a NCDOT funded projects that I'm working with NC State, and East Carolina University ECU. So basically, this big project is all about infrastructure resiliency. And so my contribution into this project is to see how we can leverage geospatial science and technology into the topic of transportation infrastructure resilience. So I was scratching my head and see what kind of aspect of resiliency that we can apply GIS into here. And since my interest is one of the interests in GIS science, to me is transportation. So I guess maybe I can look from the transportation resiliency from that perspective, and that is why I have this presentation. So we know climate change causes more frequent and extreme disasters such as hurricanes, heavy rainfall, and floods, leading to stress on transportation infrastructures like roads and bridges. And so the role of transportation in society is very important because transportation plays a critical role in achieving sustainable development goals proposed by the United Nations that we can see in that report. Transportation is also crucial in enhancing economic growth and improving accessibility, as well as enhancing resilience of cities, urban-rural linkages, and productivity of rural areas. And transportation has a great impact on social economic development, environmental sustainability, human health, and public safety, especially in urbans as they are increasingly becoming social, economic, and demographic, resulting from the steady increasing of population and urbanization. So transportation resilience is becoming more and more topic, and I see recently there are a lot of research about transportation resiliency. And why is that? Because resilience of transportation system affects the resilience of other critical systems. And a resilient transportation allows people, goods, repair, relief, and disaster responses teams to act effectively, as well as provide accessibility to essential services, while others are being restored after a disaster. And here, resilience, we consider resilience as to not only to the ability of transportation infrastructure to resist natural disasters such as heavy rainfall, but also the ability to quickly return to normal operations after a disaster. And so because I mentioned about floods events, so these are a couple of pictures that about Asheville after the Hurricane Helene, and these are the pictures. The one on the left. So last Sunday I had the opportunity to take my son to his robotic competitions in Asheville. So I met with the people there and talked with them. Kristen was the one at the hotel. I talked with her, and she has some pictures sent over to me. And also the two pictures on the right-hand side that was taken by Chris. Chris is sitting there. He's a veteran and volunteer during the event. And these are some of the pictures that I took myself. As you can see, there. This is the intersections. This is a intersection roads that currently still be closed, and they are still fixing that. Several things over there. That was because of the effect of the Hurricane Helene. And as you can see, these are the pictures that I just took that last Sunday. And as you can see, we have the sinkhole is still there, and then the intersection is still being closed. And this is actually along the road right there that is still being, being reconstructed. And so assessing and improving transportation resilience is crucial because it can help to ensure the stability of urban transportation operations, to enhance the overall resilience of cities to extreme events. And there are several, I look into, some literature review, and there are several assessment approaches that we can follow. One is the performance-based, and another one approach is performance-based, and then we also have, people can also use central connectivity metrics to assess the resiliency. We can assess resiliency through cost, through some statistical indicators and some qualitative indicators. And so in this research, like I mentioned in the beginning, I look at the resiliency from the network topology perspective. So network topology is basically, it is a term that defines the structure and arrangement of nodes or intersections and edges of connections in a particular transportation system. So as we can see in that illustrations I have there, it's a theoretical network the way you have edges that are connected to each other through nodes or intersections. So here we assessed the transportation network resiliency via through network topology by measuring the connectivity with some indices, for example, the average number of edges or nodes, or measuring the accessibility via some indices, such as the maximum distance among all shortest distance between origin and destination pairs. So how important of network topology toward the resiliency goal? The reasons that, to me, the network topology is very important and can be, a way for us to assess resiliency because, a collapse of a particular network or an edge may cause disruptions of the entire network, or the removal of nodes with high degree of connectivity might turn the network system into very vulnerable. And so from there, this is, I came to the goal, objective, and research questions of my project. So the goal here of this research, of this particular research, is to assess the resilience of road networks under random events, such as natural hazards. When I say random events, meaning that we don't know where exactly it will happen. It would just happen somewhere on our network. And so the objective of this research is, number one, is to quantify changes in service area coverage of essential services due to some random disruptions in the transportation network. And number two is to compare and contrast service area coverage in 5 North Carolina cities, Asheville, Charlotte, Durham, Greensboro, and Raleigh, to determine network vulnerability by taking a look into how the service area decreases when there are random events happens. And number three, object three, is to identify how the geographic distributions of essential services impact accessibility under disruptions. And so with that, three research questions are here. Number one is how the service area coverage of essential services change as network disruptions increase. And number two is which of the 5 NCCTs demonstrates the highest vulnerability to network disruptions. And number three, how the spatial distributions of essential services might affect their accessibility when random barriers are introduced into the network. And so just to give you some idea about the story areas that we are looking into, and in fact, about these cities, and maybe more than I do, but here I pulled up some data just to give us some idea. So on the map here, you're seeing the envelope of the networks that goes in and surround Asheville, Charlotte, and Durham, and then next slide we have Greensboro and Raleigh. But the red triangle there represent the essential services buildings that I extracted from the building footprint data, and it's not a very good data, as you will see. Oh, as you can see here, Charlotte has only one, which is definitely not correct. But that is what that is the data that we have. And some of the parameters, some of the parameters that define the study areas that I'm presenting at the bottom of the slides, with the envelope area, total road length, total junctions, and buildings, and essential purpose buildings. And so maybe at this point you question, oh, what do you mean by essential purpose buildings? And I will talk about that a little bit later. But this is the two other study areas. We have Greensboro and Raleigh. And so regarding the data that I use in my research, one is the NCDOT road geodatabase. Actually, I'm very happy and very proud of the state because NCDOT has a very, very good road data that has not only the spatial data, but also the attribute data is also very good. So I was able to develop or build the network of the state with NCDOT road data. In that road network that I built, it also has the travel time and also the driving directions as well, which help to better analyze the driving direction as well as the service areas when we run network analysis. And then regarding the essential services that I mentioned, I utilized the North Carolina building footprint, and I look into its metadata. I think this particular data was developed by FEMA through its hazard program. And as you can see on the table beside, so there are a lot of the building in our state, and there is also very good attribute data for these building footprints as well. So I look into these the attribute data of this footprint and extracted the buildings with those codes. As you can see, I extracted personal and repair services, hospital, medical office, clinic, schools, libraries, and colleges and universities, because I believe that these are essential services, and everyone would need need accessibility to these services daily. Okay, so with that, I went on and did some data analysis in terms of methodology. First of all, pre-processing. The first thing is to generate the geographic envelopes of the city based on the census places, and then clip NC roads, calculate lane travel time, and build a network data set like I mentioned before. In here, like I said, we have impedance with as travel time or minutes, and then extract building footprint. And that last point I think is quite important because it's actually the main approach that I'm using here. So basically, in my analysis, I ran in order to assess the vulnerability of network. I actually assessed the network vulnerability from accessibility standpoint. So I just want to see, with the given location and distributions of the essential services, how accessible it is to assess them with the existing network configuration, and what happened to accessibility when we have when some of the edges are disrupted or being being damaged. And so in order to do that, I ran different analysis scenarios. So here, as you can see, I have 6 scenarios. Basically, I throw in the first scenarios, I throw in there, I just randomly, throw in 5%. Pick up 5% of the edges, and I consider them as barriers, and see how, and see so how accessibility to those essential services would be. And then in the second scenario, it's just randomly pick 10% of the edges and consider them as barriers or disrupted, meaning that no traffic will be able to move through them. And then the third scenario is 15% and 20% and 25, 30% of the edges were corrupted or become barriers of the transportation network. And also, I ran network analysis, specifically service area analysis, to quantify the service area coverages of the essential places, or the red triangles that you saw at the beginning, with and without random network barriers. And like I mentioned, the network barriers, I have different scenarios. 5% of the network was had barriers, and 10%, 15%, and so on. I also when I ran the service area, I had several cut-off, like 5 minutes service area, 10-minute service area, 15-minute service area. I also, because one of the interests that I like from this research is to look into how the distributions of these essential services may impact on the accessibility, especially when disruptions happen. And therefore, I just want to measure the geographic distribution of those essential services and see how maybe it can affect or related to the change in the service areas. So a couple of findings here. First of all, is spatial distributions of essential services. As you can see here on the red triangles represent the locations of essential services or essential places that are extracted from the building footprint. And the pink circle or ellipse, those are actually the standard distance that basically help us to see, visualize, and quantify the spatial distributions of these essential places. So we can see here, Asheville has a very elongated, based on this data, very elongated distributions, but it's very concentrated in along a particular corridor. This is very different from the Durham or Raleigh, where the essential places are more dispersed over the space rather than concentrated. And so this chart shows how the square mile of service areas decreases as I introduce the barriers or disruptions into the network. And this is the outcome for the 5-minute cut of a service area. So basically, I start with service area. We spread out and go out 5 minutes and see where that coverage is. And then, with and without the barriers. And then I record the square mile of that service area and then draw this chart. So as you can see here, almost all cities, of course, when we introduce a disruption into the network, the accessibility to the service areas is going to be reduced. As you can see, the reductions of square mile of service areas of the different cities, Greensboro, Durham, all other cities are very similar. However, the top line, the line right here, this represents Asheville. Very interesting because the decreasing rate is higher than the decreasing rate of all other cities. And this is for the 5 minutes cut off of service area. This happened the same thing with the 10 minutes cut off. As you can see, Asheville has a higher decreasing rate as compared to all other cities. And it's all on 15 minutes. And this is all of the 5, 10, 15 minutes, all of them together. And so this is just a spatial geographic visualizations of how the service area changes as we start to introduce barriers or introduce disruptions into the network. The one on the left here that doesn't have any disruptions introduced. As you can see how large the service area is. And so the blue color actually 5 minutes cut off, and then the yellow is 15 minutes cut off, and the 10 minutes cut off it's not go much further than the 5 minutes cut off with the existing configuration of the network. But when you start introduce 15%, if 15% of the road edges became disrupted, as you can see, there was a significant reductions in terms of the accessibility to these essential services. Or in other words, the service coverage of these essential services are very much reduced. And then when 30% of the road network was disrupted, it means like no accessibility to these essential services at all. And so this is going to be for Durham, as you can see, that's reduction. And so time is there, so I'm going to just fly through it real quick. So conclusion, so all networks of the 5 cities are vulnerable and to random events with various degrees, causing critical decline in service area coverage of essential services. Asheville specifically, as you can see, despite starting with the largest service area, experiences extreme losses and emphasizing its dependency on an uninterrupted network. And vulnerability of all networks is potentially the same when 50% of the edges are randomly disrupted. And it is finding also suggests that the need of redundancy in transportation planning to maintain access to essential services during disruptions. And the last point is it seems like the geographic distributions of essential services might have some potential effect on the vulnerability of the network, which, even though this one, I need to look a little more deeper into this particular relationship. But it's very interesting that we can start to see that now. But with that, thank you very much, and I'm very happy for your questions. More time. Yeah, yes, sir.
Have you started to associate different network lines with different vulnerabilities like flooding and maybe landslides or any other type of like railroad crossings where you might have a train derailment, and try to target your disruptions to either natural events or artificial events of disruption?
Yeah, that's a very good question. No, yeah, thank you for the questions. So I actually did not separate natural event or a man-made event just yet. So here I just look into random events, and that random events can be natural or human-made. But definitely that is something that's a very good suggestion. I think something that I should look into. Thanks. Any other questions? Okay. All right. Thank you.